Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor Space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Thank you, Danny. Hi, everyone. We're excited to have you join us today. Before we dive in, we'd love to hear where you're tuning in from and what you're hoping to gain from this session. I think it's always fascinating to see our global reach here at Microsoft. In this session, we'll be going over how to uncover AI insights using Azure Cosmos DB mirroring in Microsoft Fabric. I'm Jailene Maldonado, Program Manager on the Azure Cosmos DB team. And with me, we have Hossein Harris, Principal AI Engineer from the Applied AI team in Microsoft Fabric. For the next hour, we're going to look at how Azure Cosmos DB is positioned to handle Gen AI requirements, how customers are using Cosmos DB for their AI needs, and then look at analytics on AI data using mirroring. The bulk of today's session will be the demo that Hossein has graciously put together for us. And this demo will show how to get insights on a chat history application using mirroring in Microsoft Fabric. Please feel free to shoot any questions you have throughout the session in the chat, and someone from our team will try their best to answer them. So let's get started. AI today has become quite the hot topic. It's not just a buzzword, though. It's a powerful tool in any dev's toolbox. We're seeing many customers using AI to transform their businesses by increasing efficiency of their products, processes, and people. Using the power of AI, they're able to detect security anomalies, optimize supply chains, increase employee productivity, and even provide personalized customer service using AI-powered chatbots. AI applications tend to have specific requirements, including managing large volumes of data at high scale and fast storage and retrieval. Also, since these applications tend to have direct human interaction, you need high reliability as well. Luckily, though, these are all strong suits of Cosmos DB, making it the perfect choice for your AI application needs. Now, I'm not just biased. In a recent survey done by Bloomberg Intelligence that you can see on the left here, 26% of the CIOs surveyed chose Cosmos DB as their top choice for LLM and RAG customization. With instant autoscale, Azure provides high elasticity to suit the needs of highly dynamic AI. As a matter of fact, OpenAI relies on Cosmos DB to dynamically scale ChatGPT sessions. It's a highly performant database that offers low latency, real-time data transactions, and mission-critical reliability for your AI workloads. With built-in vector indexing and ability to search with disk A9, Cosmos DB is positioned to best fit your AI application needs. Now, there are a lot of AI scenarios you can power using Cosmos DB. For instance, in the realm of chat history, many customers rely on Cosmos DB to store and quickly retrieve chat messages, making it an excellent choice for AI-powered shopping assistants and live customer support. Organizations like KPMG leverage Cosmos DB in applications such as KimChat, which enhances employee productivity through chat-based interactions. Additionally, customers are also using Cosmos DB RAG or Cosmos DB for RAG pattern apps by accessing both structured and unstructured data. These applications enable large language models to provide more contextual and relevant answers. We have many ISVs building multi-tenant applications on Cosmos DB, leveraging its AI capabilities to effectively tap into this growing market. For example, ASOS uses Cosmos DB to store predictions for its real-time recommendation systems, while MasterCard employs it for real-time anomaly detections. Finally, customers are integrating multiple AI models or agents to collaborate, resulting in improved AI responses. So in summary, all of these scenarios can be seamlessly supported through Cosmos DB. Now let's explore a specific AI use case. Businesses can achieve a lot of value analyzing the AI data stored in Azure Cosmos DB, and this example will focus on the chat history of an e-commerce business. By gaining rich insights from chat data, businesses can perform sentiment analysis to gauge the tone expressed in conversations. This not only enhances user engagement through improved responses, but also helps assess overall customer satisfaction. Utilizing live data allows you to examine keywords and identify critical trends. For instance, if there are ongoing shopping delays leading to an uptick in customer complaints, timely analysis can generate alerts to address these issues quickly. You can also enhance supply chain efficiency by applying similar trend analysis. Additionally, this approach allows you to optimize the performance of the chatbot itself. Now, when we analyze AI data, there are a few important aspects to consider. First, the analysis should be cost-effective, especially when dealing with large volumes of data. It's also vital that this analysis doesn't disrupt the performance of the AI application, and we must be able to conduct the analysis on live data to ensure that we can respond quickly to business events. There are several ways to enable analytics on Cosmos DB, so let's take a closer look at some of these options. So with the first option on the left, you can run Spark queries directly on your AI data in Cosmos DB. However, since analytical queries are complex, they will impact the performance of your AI apps. They could also slow down analytical queries themselves, which, as we just mentioned, is not what we want. Now, most organizations typically have a setup like the one shown on the right, which is our second option. They bring all of their organizational data into a central warehouse, and this is done periodically using ETL. This saves the database from performance impact and prevents any slowdown caused by analytical queries. But at the scale of data generated for AI apps, this is highly complex and costly, and in this case, the key insights are delayed. To address these challenges, we introduced mirroring at FabCon earlier this year, and this is now in public preview for Azure Cosmos DB. With mirroring, we are simplifying data movement for analytics without the need for ETL. You can enable mirroring on your existing Azure database with a few clicks. Once mirroring is enabled, your database data is replicated seamlessly in Fabric OneLake. Data is stored in Delta format, ready for analytics, and any new inserts, updates, deletes are incrementally replicated in near real time. Once the data is in Fabric OneLake, you can enable all of the analytics and AI experiences without further data movement. Note though, for Azure Cosmos DB specifically, you will need to enable continuous backup on your Cosmos DB account as a prerequisite for mirroring. With mirroring, we're making it easy to move data from your databases into Microsoft Fabric. Thanks to no ETL and built-in replication, mirroring offers a less complex and more cost-effective solution compared to traditional ETL processes. We ensure performance isolation for your database data, allowing your AI apps to scale independent of the analytical queries. And you can also gain valuable insights from real-time data landing in Cosmos DB. And on top of that, mirroring allows you to unify your data estate since the data in Fabric OneLake is accessible to any platform that supports Delta. Finally, with Fabric OneLake, security and governance is also simplified. Here are a few experiences you can get once the mirrored data is replicated into Fabric without further data movement. You can analyze the data using T-SQL and SQL Analytics Endpoint. You can add a mirrored database as a shortcut in Lakehouse and run Spark queries or build data science experiences using machine learning. You can enable Power BI with the amazing Copilot add-ons with a single click. And finally, you can analyze this data in Azure Databricks or any services that handle Delta format. Now let's hear from Hossein on how to enable analytics and BI on chat history data stored in Cosmos DB.
Thanks, Jailene, for your insightful introduction into Cosmos DB mirroring feature, its importance. Now let's dive into a use case and see how we can leverage the power of mirroring alongside Fabric's other analytics tools to derive insights from chat history data. The demo material is provided at the link that is on the slide, so you can access the demo material. So let's look at a concrete use case of an e-commerce company. The objective is to get product feedback and sales strategy insights from a chatbot history data that is stored in a Cosmos DB database. A typical interaction for a use case like this, which is an e-commerce chatbot, is that a user goes on a platform, asks about a certain product, for example, a recommendation for a specific product, or gives feedback about a specific feature of a product, for example, its size, its usability, or other aspects of the product. And all these valuable information is unstructured and is all stored in a database. And what matters is that business stakeholders would like to ask and answer some key questions that can guide their decision makings in a data-driven fashion. For example, when the data that's available in as a chat history format, we might want to be interested to know what are the trends in pricing feedback that could potentially suggest opportunities for any sort of promotions or price adjustments. I'd like to know how frequently a brand is mentioned in a conversation, what are the trends in brand mentions, and if there's any need for marketing activities or product launches. And there are a lot of other valuable information, for example, what is specific sizing issues users are reporting with a particular product, and so on and so forth. So the objective of our demo today is essentially we want to see how we can go from this chat messages that are in a unstructured format into distill that information into insightful, actionable data that can be used for data-driven decision making. And this could potentially also be presented nicely in a dashboard as well. Before I dive into the actual demo itself, I just want to mention that for the purpose of demo, we are going to use synthetic data in order to avoid the complexities of collecting real-world data, such as PII, etc. So in this case, we are using LLMs to generate synthetic data for us. We are instructing the LLM to be an agent that can generate conversation about products. And we are also, as an input, we are giving the name, type, and description and price of the products to LLM. And the conversations are randomly generated from these products. And also we instruct the LLM to follow a specific tone for user questions. The prompts and details of this synthetic data generation is available at the link provided on this slide. Now let's look at the overall solution of architecture and see how we can, at the high level, approach the problem and solve it. So on the left side, there is a chatbot that interacts with the user and keeps storing the data in Azure Cosmos DB for NoSQL database, for example, but it could be any database for that matter. And then with Fabric mirroring, we can bring all the chat information inside Fabric and make it available in one link. And via a shortcut, we can then bring that data into Fabric Lakehouse, where we can do all sort of analysis on the data. For example, we can use Fabric Spark, where via Fabric Spark, we can also make Azure OpenAI calls and do analysis. And eventually, once the analysis is done, we can create a semantic model and showcase the result in a Power BI dashboard. Now let's look and focus on the first part, where we want to take the data that's stored in the database, bring it into Fabric, and also create a shortcut in a lakehouse. For this part of the demo, we have already created an account in Azure Cosmos DB. And if you follow the README that's provided in the GitHub link for the demo material, you can also see the steps that is needed to create a Cosmos DB account for NoSQL. And in this case, we have some chat history data that's stored in a database. In a container. And as you can see on the right, these are some typical interactions, right? There is multi-turn interaction between a user and a chatbot in the form of question and answer. And all these messages are stored for each users. And we have about 900 something of those interactions. And what we want to do next is we want to take this data and bring it into Fabric via mirroring. This part of the demo can be achieved with a trial version of Fabric as well, so you can try it out for yourself. And at this stage, like, you need to open Fabric and then create and click on New Item. You go either to All Items, or in this case, I've made Mirrored Azure Cosmos DB as my favorite. I click on it. When you want to perform mirroring for the first time, you need to make a connection between the database and Fabric. And for that, you need to click on this link. I've already done this part of the demo because I didn't want to share my account keys in a live demo. So all you need to do, fill it out, create a connection. And once that connection is there, you would see that it would appear here. And in this case, this is the connection that I've created between the database that I showed earlier and Fabric. So it might take a couple of seconds between everything gets in sync and you're able to see that Fabric had found the databases that are linked. So in this case, if you recall, the information is inside chat demo database. So next we will connect. At this stage, we want to choose which data we want to connect. And in our case, we only have the chat history, so we will use that. And we can give it a chat demo 1, for example, or something like that. And we create a mirrored database. At this stage, what's happening is that the data from the database gonna be pulled into Fabric OneLake. And typically this process can take a minute or so in order for Fabric to replicate all the data that is in a database in a OneLake. Once you're here, you can monitor replication and see how the replication process is going. As you can see so far, it says no data has landed. As I mentioned, typically as you can see here also as a note, change may apply up to 60 seconds to appear. So we might to refresh a little bit to see, to make sure that the data is available. Now it appears that our replication process has started and the data is being replicated. But we still have 0 rows available. So we need to wait until we see all the rows appear here. While this replication is happening under the hood, also wanted to mention that there is SQL Analytics endpoint that you can benefit from, where you can, once the data is replicated in one lake, you can also query and check your data sanity, etc. So now, as you can see, all the data is replicated, 994, perfect. And as I recall, each of these rows contain 10 to 16 rounds of interaction. So we're talking about over 10,000 messages being replicated here. Now, just quickly, as I talked about the endpoint, is that you can take advantage of that as well. So if you want to, for example, query here, you can quickly do that as well. So that gives you a very nice, like easy and nice way of inspecting your data, etc., and see like how the data that is mirrored into Fabric. So the next thing we want to do is we want to take the data that is in the mirrored database or one lake and put it in a lake house for subsequent analysis or sophisticated analysis that we want to do after. So what we can do is now like create a lake house, like we call demo 1 lake house, just given the name. We are gonna, at this stage, what we are going to do is via a shortcut, we are going to bring the data into a lakehouse. So at the first stage, just a quick note is that we are replicating the data into one lake via mirroring, but via shortcut, there is no replication. We're just creating a reference inside a lakehouse. So no duplication of data at this stage. So get a new shortcut. The shortcut we want to create is that we want to grab it from our one lake. So if you recall, we had mirror database that we just created. Next, we are going to select the chat history. This is the data that we want to bring to our lakehouse, and then click on create. So at this stage, we have created a shortcut between the data and in data that's in one lake and the data that's in our lakehouse. What we want to do next is perhaps like quickly inspect it in a notebook. So we are going to create a new notebook, and we are going to load the data into Spark. And that allows us to do all sorts of scalable analysis using Fabric Spark. And that means that if you have data that scales to millions, you can easily do that inside Fabric Spark Notebook. Just one note here is that when you're running Spark, we are initiating a Spark cluster, right? That warm-up period adds a little bit of time. When there's a small data set, that might look like an overhead, but when there is a huge data set, that's where Spark shines. So if you look at here now, all the data that we had in our database is readily available inside a Fabric data frame for our analysis. Next, what I'm going to do is, in real-world application, what happens is that the chatbot keeps writing data into the database, and we want to emulate that process by uploading more data into the database and see the mirroring in action. So now I'm going to upload part 2 of the chat history data, which adds, say, additional 1,000 interactions with the user. And as I mentioned, in real-world applications, it just keeps adding the data in a continuous way. We are, for the benefit of showcasing it, I'm just going to upload it in a one-shot. So as you can see, we added additional 1,000 data sets, 0 throttle. That's fantastic. Now we can go back to Fabric and we can go to mirror database. And what we want to see is that originally, now that we have 994 rows, now we have added 1,000 more data and should be able to see that this appears here as well. But as I mentioned, the whole process is near real time for many applications. It can take up to 60 seconds for the replication to happen. So that's something to be mindful about for real world applications. For example, if you're doing analysis on certain product features, etc., that's in the time frame of days and hours, this is perfectly suitable. And just a remark here that if once the data is replicated, since we have the shortcut already created, we don't need to do anything. So the data comes in to Fabric, gets replicated. The shortcut, it's already in our lakehouse. And if you have a Fabric notebook that is scheduled to run, for example, every hour or something like that, you're already benefiting from this automated process. It's taking a little bit longer, I believe, but eventually we should be able to see all the data appeared here. So we can go to the notebook as well. We can rerun the notebook. Since we added more data, the limit is over 1,000. So I need to rerun this again to make sure that we capture all the data that's being replicated. So we still have around 1,000 data. So let's go back to let's go back to the mirror database and monitor the replication again. So it seems like the replication is still not completed. So for the interest of time, I am going to continue with the demo as we need to look at the analysis section as well. So let's now focus on the second part. So once the data is available in inside Lakehouse, we would like to do a complete analysis via Fabric Spark. And our goal is really use generative AI and all the benefits of using large language model to extract the information. So our goal is to look at product brand specific sentiment analysis. We would like to look at product feature analysis, identify key product features, whether they are liked or disliked by the users. And the main benefit of this methodology is that we run the analysis over all the messages that are in the database, and we turn that unstructured data into structured insights. And here our focus is on accuracy, because we are going to iterate over the whole data set. We are able to capture all the information that we are looking for in the chat history data. At the high level, let me give you a quick example. For example, a user message something like this: I like the Venture Pro GPS watch. Its design is solid and it's very usable. The price is reasonable and the brand is trustworthy. However, I wish it had a better color option. Now we would like to see what are the key information that's in this text. We are able to identify, for example, we would like to identify the type of the product is navigation, the brand is Air Strider, the name is Venture Pro GPS watch, the sentiment of this user interaction is enthusiastic, and the features that are being discussed, and especially we are interested to know if those features liked or disliked. For example, we clearly see that what is liked is about its design, usability, price, and brand. What is disliked is color, as you can see. However, I wish it had a better color option. Now let's go to Fabric again, and I show you the notebook that can take you from this unstructured text to structured insight. Now that we are in our Fabric environment, what we are going to do is to open a notebook. That's again is available in the link for the demo material. Just as of note, when we want to run this type of analysis, we are going to use the built-in feature, the Azure OpenAI inside Fabric. That doesn't require you to bring any keys. And because of that, our requirement is to use Fabric with F64 capacity. So this notebook will not run with the trial version. So in order to extract and aggregate sentiments, we need to follow a few steps. Like obviously, the first step is to load the mirrored container into a lakehouse. That's what I've done previously here. I've also added the product catalog for the interest of time. So now we have the chat history and product catalog. And we have a table that we are going to store all the analysis results that we will use subsequently for presentation purposes. So at this stage, we will, and the second step is to extract sentiment around product features using Fabric's built-in Azure OpenAI. As a note here, before large language models, in order to achieve a task like this, we needed to have multiple models. You needed to have a named entity recognition model, sentiment analysis. You need to do a lot of feature extraction, integration, and transformation. However, with LLMs, the workflow is very simplified. So we only need a good large language model, which is a unified model. And then we iterate on prompt until we are happy with the information extraction. This makes us to do less manual effort, and it's also very scalable, right? If you have one use case versus another use case, you don't have to train another model or tweak another model. You're using just one large language model for the purposes of information extraction. So in this case, we have crafted a prompt that goes like this. You are an expert business analyst, given a conversation between a client and a chatbot. You identify the list of products being discussed, sentiments around each product, features, etc. And we also clearly specify what choices for sentiments, enthusiastic, neutral, obstructionist, choices for product features like liked or disliked, design, usability, color, size, price, and brand. And also at the end, we show a format of a JSON file that we are expecting the LLM to provide us as an output. Because we are using built-in feature, again, there are some transformations here that is also available in the docs for Fabric for using OpenAI endpoint. They're relatively straightforward. We just need to reformat the data in a way that is consumable by built-in Azure OpenAI inside Fabric. And in the following, we just create our chat completion, we apply it, and what's going to happen is that we're going to iterate over all the messages that we loaded into a Spark data frame, and all these messages are passed to LLM, and the final output by LLM is collected in a column called content. So what we want to do next is that, as you can see here, they are things that needs to be cleaned on this content to make it a very nice, clear JSON format. And that's what next step is for. We are applying a schema for targeted sentiment extraction. So we are basically, with this transformation, we are going from content like this to a clear JSON string. And now that we have this JSON format, it's still not clearly exposed. And what we want to do is we want to be able to explode this information into nice, clear columns that captures what type of, it captures the name of the product, its sentiment, etc. And it also, for one message conversation, maybe there are more than one mentions of products. So we also want to expand the rows as well to include multiple product mentions as well. So eventually we want to apply this schema to the parse JSON file and explode it to have a more clear presentation of our analysis. Basically, all this step, all of the work that is being done at this step is to just do those transformations. So as you can see, just one example is that we had a content conversation. We want to see, if the price of that product was being liked. Obviously, if it's liked, it's not disliked, so it's a binary value. There was no mention of like or dislike for that product mention, etc. And as you can see, now the information is very well represented in clear columns. And what we can do next is that we can add retrieve the product IDs, right? We have a product catalog that's known a priori, and then there are certain products that are being discussed in the messages. And maybe there are some products that actually are discussed in the chat messages, but are not part of the product catalog. So we might want to filter them and things like that. So it's really beneficial to also integrate product catalog and add it to the data frame. And finally, once we've done that step, what we want to do is to aggregate and summarize product feature sentiments and count them. So far, we've been going through each individual message, identifies if a product is discussed and whether or not some of his product features are mentioned or liked or disliked. In order to have a statistically significant results, we want to aggregate and make counts. And this is the step to achieve that. And again, for the interest of time, I will I just want to mention that if you'd like, you can go again to the demo material and you will see the details of how this is done. But at the end of the day, what we are achieving is for the product mentions, we are aggregating how many times the products that are discussed in the chat conversation being liked or disliked. And finally, once we have that aggregated information, we will store it in the chat analysis results. What you can do also is to optionally write it back into the database as well. So the last section is making use of Spark's OLTP to do the write back, but that's really optional if in case you want to consume that analysis results later in another application or something like that. So with that, this concludes the analysis part. And what we want to do next is that now that we've get the data, how can we show it in a Power BI dashboard? So in the next step, what we are going to do is to go to our chatbot lakehouse that is in our workspace, and that has all the information or the table that's needed for building a Power BI dashboard. So now if you look at here, we have all the products with their names and types and brands and number of mentions, like the aggregation results. Now let's see how we can showcase these results in a nice dashboard. So the next step from here is to go and create a new semantic model. In this example, we are only using a single table, so we don't need to create any relations, etc. So that's more straightforward in a sense. So I just simply create a new semantic model, give it semantic test demo, confirm. And once the semantic model is created, and as again I mentioned, because there's a single table, there is no specific relations, but you can also, if you have multiple analysis tables, you can also define the relationships between those tables. And since there is none here, it's more straightforward in our case. You can see the chat analysis data. What we are going to do next is to create. At this stage, if you are a savvy Power BI user, you can use your skills and create a dashboard. However, I personally prefer to use Copilot and perhaps suggest content for a new report. And as we can see here, its suggestions are about product feature preferences, brand performance, etc. So we can simply pick one of these as a demo for a demo purpose and create a dashboard. And again, it's really once you have the data here, it's all up to you how you want to create, what type of reports you want to create here. But as you can see, what we've so far created is the mentions of the product feedback by brand. For example, we clearly see that Wild Runner has the most enthusiastic feedbacks. There are some neutral feedbacks. There are some obstructionist feedbacks. For example, Daybird product has been, the feedback was relatively negative during the chat conversations by the users. And you can also see the breakdowns as well. Like you can see, for example, Skiboard, etc., has been, the number of mentions or highlights, etc. So at this point, it's again up to you how you want to create the dashboard and convey the results to the business stakeholders. With that, I also wanted to here conclude this part of the demo and pass it on back to Jailin to conclude this presentation. Thank you very much.
Thanks, Hassan, for that amazing demo. So in this final portion, we'll just wrap things up. Let's see. There we go. So as mentioned, mirroring is currently in public preview for Azure Cosmos DB. Currently, we support schema evolution, so if you add new properties or remove others, we will automatically handle this. Also, we will support nested data, which are shown as JSON strings, and you can utilize OpenJSON in T-SQL or flatten using Spark. Mirroring can also serve as the bronze layer in medallion architectures by replicating raw data into your mirror database, which can then be cleaned and transformed in subsequent layers. We're working hard on more capabilities from now to GA and beyond. At a high level, we will address known product limitations such as JSON string limits in data warehouse, column name handling, and the ability to allow mirroring specific containers. We'll be adding support for auth with entry IDs and service principal, virtual networks, and auto schema inference for SQL. Now, the key topic of pricing. We have great news. With mirroring, any compute used for replicating data is free of cost. Storage is also free up to your capacity limits. For example, if you're using F2 capacity, up to 2 terabytes is free, and OneLake charges apply beyond that. Standard charges apply for regular usage of Fabric services such as SQL queries, lakehouses, etc. If you enable 30-day backup for mirroring, you will accrue standard charges for the feature. This is why we recommend 7-day continuous backup, since it's free if you're specifically enabling this for mirroring. Here's a quick roadmap on mirroring. We announced Snowflake GA last month and are committed to bringing more data sources into OneLake like SQL on-prem, MySQL, PostgreSQL, and MongoDB. And I know there's a lot happening on the screen, but if we look at these 3 categories with mirroring, multi-cloud, shortcuts, and open access APIs, you can seamlessly bring data from varied sources into Fabric OneLake. This enables you to unify your data state in OneLake, simplifying end-to-end analytics for your entire org, and ultimately breaking down these data silos. To wrap up, I really want to drive home the importance of establishing strong data gravity, because this is what truly sets you up to maximize the power of your analytics. And with Cosmos DB mirroring, you have the missing puzzle piece that can make this possible. Thank you so much for your time. I hope that you found this session useful. And if you have any questions, you can reach out to the email listed here. Best of luck to everyone and your hackathon projects.